Hello guys, welcome back to VC Tech. Have you ever wondered how two completely different networks that are miles apart can communicate as if they are directly connected with a cable? What is happening behind the scene? Well, in today's video, I'm going to show you exactly how that is possible using a powerful technology called GRE, a Generic Routing Encapsulation. For this tutorial, we are going to be making use of 3 routers and 2 host devices for each local area network. We also have our Site A router and also our Site B router. Before we get into the configuration of Generic Routing Encapsulation, let's talk about what Generic Routing Encapsulation is and how it works. It is a tunneling protocol that allows one network to send its data across another network by wrapping the original packet inside a new IP packet. In a simple term, GRE creates a virtual tunnel between two routers, allowing them to communicate as if they are directly connected. Now, how GRE works is GRE encapsulates the packet. That means it takes the original packet and puts it inside another packet. So first we have the outer IP header, which is used to send packet across the internet. And we also have GRE header, which is used to identify the tunnel, as well as we have the inner packet, which is the actual data. I know it sounds a bit confusing, but when we get into the configuration, it is going to be very much clear. So since you know all that about GRE and you know that it is used to hide or it is used to encapsulate packets inside another packet, let's get into the configuration phase of Generic Routing Encapsulation. So on this router, I've already configured a routing protocol so all the routers know how to connect or know how to get to each other. If we try to ping from this device to the second local area network, which is the Site B local area network, we are able to ping the device in Site B local area network. So it means our connection is accurate and active. Now let's configure our GRE on the Site A router, and we are also going to do that on the Site B router. So on the Site A router, how we configure GRE, we say interface tunnel with a tunnel number. We'll be using 10 for this. And the options we get when we get into the interface tunnel is we have the exit IP, IPv6, no, shutdown, and tunnel. First, we want to assign IP address to the tunnel. For this, it will be taking 172.16.1.1.1 with a subnet mask of 255.255.255.0. Now, let's also create tunnel. So tunnel, we want to get the source. So the tunnel source of the Site A router is the outgoing interface of the Site A router. So we are going to use the interface, which is serial 0/3/0. This is going to be the tunnel source, and the tunnel destination is going to be the outgoing interface of the Site B router. That is the tunnel destination because that is where we are trying to get to. So the destination will be taking the IP address of this interface over here, which is 10.0.1.1. So 10.0.1.1. By doing this, we've configured a tunnel on a Site A router. So what we just did is we created a tunnel with a tunnel interface number of 10. We also assign an IP address to that tunnel, as well as we created a tunnel source to be using the outgoing interface of the Site A router and the destination and the tunnel destination of the outgoing interface of the Site B router. Now let's head over to the second router, which is the Site B router, and do the same configuration. Then we try to ping and see what happens. So on the Site B router, we say interface tunnel with a tunnel number of 10.
we want to assign IP address to it. Remember, the site A router took 172.16.1.1 in the site A router. However, for the site B router, it will be taking .2 with a subnet mask of 255.255.0. Now, mainly looking at this, you're going to think that the both routers are directly connected, but they are not. However, they are virtually connected because GRE is a virtual point-to-point connection between two routers. What we are configuring right here is we are trying to enable this router to communicate with this router virtually. So now let's create the tunnel source. So the tunnel source for the site B router is going to be the outgoing interface of the site B router, which is this interface over here. So we are going to see serial 0/3/0, and the tunnel destination is going to be the outgoing interface of the site A router. So we are going to be taking the IP address of the outgoing interface of the site A router, which is taking the IP address of 10.0.0.1. So on the site B router, we say the destination will be 10.0.0.1. Now our tunnel is up. Site A can now communicate with site B as if they are directly connected. Let's ping from this device and see what route it is going to be taking. We are still able to ping the site B router. However, if we try to trace route to see what route it is taking to get to that destination, you're going to be seeing that it is still taking the actual path, which is from this router up until this router before it gets to this router. So let's trace route and see what happens. So 168.2.11. So as I said, it left our default gateway, then it passed through this interface of 10.0.0.2 and 10.0.1.1 before it got to its actual destination. Even though GRE creates a virtual point-to-point connection between two routers, traceroute will still show intermediate routers because packets are physically transmitted through those devices. GRE only encapsulates the traffic. It does not eliminate the actual paths taken across the network. However, if we try to trace routes using 172.16.1.2, you're going to see that we are able to trace routes from it left our default gateway and it got to 172.16.1.2. So what GRE does is it provides a logical adjacency, not physical adjacency. In a simple explanation, GRE is like having a private conversation through a phone call. It feels like you're directly connected, but remember the calls still have to pass through multiple telecom systems. So that is how GRE works. So devices from site A can communicate with devices from site B. They are going to be taking the path this way. However, the packet is encapsulated inside a GRE header, meaning the private IP of this local area network will not be seen, only the IP of the tunneling that we are using to get to site B network. If we try to troubleshoot by saying do show IP interface brief, you're going to see that our tunnel is up and it has the IP address of 172.16.1.1. So a simple takeaway from this tutorial is GRE hides the traffic, not the path. So the path that the traffic will be taking to get to its destination will be the same path from the first router to the second router before it gets to the final router. However, GRE hides the traffic by encapsulating the private IP into using the tunneling IP address. So it is allowed to say that GRE allows network to communicate across different infrastructure by encapsulating the packet and creating a virtual connection that behaves like a direct link. The configuration we just did is a virtual connection that behaves as if the both routers are directly connected. But while it solves connectivity problems, it does not provide security, which is why it is often to combine GRE with IPsec in a real network environment. If you find this video helpful, make sure to like and subscribe and drop a comment, especially if you want a full GRE with OSPF. On the next video, we are going to be talking about GRE with IPsec. Stay tuned and I hope to see you in the next video.